Now, I don't think there's anyone's going to argue that the left-hand side is more complicated than the right-hand side, but you could have started on the right-hand side if you want. I'm going to start on the left-hand side, and that is just wickedly complicated looking. No trig functions being squared, so I really can't use Pythagorean identities. It's already in sines and cosines, so there's can't use that hint. Well, let's just use arithmetic, right? What is it asking us to do? It's asking us to add these fractions, so let's do it. In order to add and subtract fractions, they need to have a common denominator. So the common denominator is going to be the sine and cosine together. So this fraction needs to be multiplied by sine over sine. This fraction needs to be multiplied by cosine over cosine. For the sake of this video, I'll show my work. So we have sine of x times cosine of x plus sine of x all over sine cosine. So you can see here's the original fraction, and all I did was I multiplied the numerator and denominator by sine over sine to get the common denominator. Plus cosine of x times cosine of x minus sine of x over sine of x cosine of x. And again, just to show my work, here is the original fraction here, and all I did was I multiplied top and bottom by cosine of x. So now that they have the same denominator, we can put them together as one fraction, sine x cosine of x, and let's go ahead and distribute at the same time. So that's sine x cosine x plus sine squared x plus, so we don't have to worry about any any distributing of a negative, plus cosine times cosine is cosine squared x, and then this right here would be a negative or a minus sine x cosine x. It's technically cosine times sine, but you can flip it because multiplication is commutative. And then from here, we should have noticed that these guys cancel, one's positive, one negative, and we're left with sine squared plus cosine squared, which, according to Pythagorean identity, is just a 1. So notice how we have 1 over sine x cosine x. They are in the denominator, they are reciprocal. So we should know that the reciprocal of sine is cosecant, and the reciprocal of cosine is secant, which I think is exactly what we wanted, right? Yep, cosecant x times secant x. That's precisely the right-hand side. So, pretty cool, pretty simple.